Right, so let's get started. So the Public India session will be chaired by the Dr. Badi Yarab. So to the podium.
Good afternoon to you all. I and my two colleagues would be representing the India session here, and we would like to extend our thanks to GEMM Asia Summit for this excellent opportunity. When we look in today's context, climate change is indeed a planetary or an existential crisis. And we would find that right from the streets to the stratosphere, as we may say, from the plastics that rain in the, which have reached the deepest point in the international oceans, to the ozone, the aerosols which have destroyed the ozone. All these issues have affected human life as never before. We would see that climate change is affecting people life and livelihoods across the world, and especially in India. It has a particular vulnerability. And in that context, the adaptation policy has come up more in terms of its intensity, in terms of its content, and its impact as compared to the mitigation policy, which is sometimes questioned. So this is, and of course, apart from, because in the morning there was Jolene perhaps who pointed out that there are small states, island states, that would soon cease to exist. And even in India, we find there are many parts of India that are really prone to such a kind of existence. The existence which is really called into question, because in coastal areas, especially in Mumbai, Kolkata, Visakhapatnam, there are major chunks of these Indian cities that would also cease by 2050. So it is in this context that heat wave and urban flooding that has come up very rampantly in the recent past, they acquire particular significance. So I would be now calling upon first Professor Kansal, who is a professor at the Indian Institute of Technology and Roorkee, and he would be speaking on sustainability in the Indian Himalayan region.
Thank you, ma'am. First, I would like to thank GEMM for inviting us for this summit. And we hope that from the morning, we are discussing about the air and environment issues. And we know that next to air, water is the most important aspect, which is affecting the environment. So basically, the water we require for various purposes, like for drinking, for eating, or for energy purposes. And we have to think of the water security, food security, energy security. And whenever we are going for these various securities, we have to think of the healthy environment as well. As we were discussing in the morning also, that the various pillars of the sustainability are the society, environment, as well as the economic activities. And the key to the sustainability is that how much resiliency in the system is there, or how we can take care of the various stressors which can be there for the like the climate change or any other stressors. So basically, in the morning, one model was shown that the pressures, the impact, the stressors, and the response of the system, etc. So from that aspect, the three aspects are important. And beside these three aspects, the fourth one is the technology, that how we can use the technology for the sustenance of our society. If you see the India's water resources, that we have the Himalayan region at the top. And the major source of the water in India is through the rains which are caused by the Arabian Sea or the Bay of Bengal, when the clouds strike the Himalayas and then the snow melt as well as from the Himalayas. So the water goes in the various rivers, and the major river systems are the Brahmaputra, Barak, and Ganga system, which is almost 60% entire surface water comes from this river system. And in the Ganges system itself, about 650 million population is there in the Ganges system itself, if you see in the top part. And the other issue in India is the population. As of today, our population is almost 1.4 billion, about 1400 million population. And the water availability, there is a lot of variability in space as well as in time. For example, say the average rainfall in India is about 1200 millimeter, which varies from 100 to 12,000 millimeter with a coefficient of variation of 15 to 70. And the number of rainy days in a year are only 100. So we need in various parts of the country to meet the requirement for the entire year. And the moment we go for the various storages, we face a lot of problems. The various problems associated with water in India are, in a nutshell, related with the quantity. We have the water scarcity issues, we have the floods, we have the droughts, and there is a mismatch of the supply and demand. Just go to the next slide. For example, no, not this one, quantity related. Yeah. Because when there is a scarcity of the water, we have to think of that how we can provide the sufficient water to the people. That is the issue. And then there is a lot of leakages in the water distribution system, urban water distribution systems. There is a conflict with the other water users. Next, please. Like the various flood events, what Dr. Bharti was just talking about, the famous, the 2013 floods, huge flood came and a lot of people died and a lot of properties got damaged. Next. Then the various actions which are required for the flood management and control is the structural measures as well as the non-structural measures, and this requires the proper monitoring of the data or the flow in the Himalayan regions. Next. There can be the drought in the western part, particularly of India. So people are having scarcity of the water. Next. Then from where this water scarcity can be met? This can come only through the new dams and the canals, the intra-basin transfer or the inter-basin transfer of the water, or through the rainwater harvesting or groundwater or water saving, or even the water productivity. And for all these, we have to monitor our resources. We have to monitor the waters. Please go back. Then the second issue is about the quality related. One is the drinking water issues. The various codes are there, like the WHO or US EPA or Indian standards are there. So generally safety of the water is ensured at the treatment plant, but no guarantee is given at the consumer level. Whereas we as society, we are, it is important that the water quality should be good at the consumer level, and the water quality deteriorates in space and time, maybe due to internal decay or because of the accidental contamination. So therefore, the water quality modeling, direct as well as inverse modeling, is very important. Next. The other issue about the water pollution is the untreated sewage and the industrial disposal. Most of the time, this disposal is carried out in the water bodies, right? And there is lack of monitoring as well as the lack of the data for this implementation is there. So the water bodies are getting polluted. Next. Then the major issue, another comes is about the solid waste management. The most of the time, the solid waste is dumped into the rivers, and because of the organic, the biodegradable trash, the oxygen demand gets increased and the oxygen demand level goes down. And particularly During the COVID-19, also many bodies were vast and in the water bodies, and there was no control mechanism as such for that. Next. The other issue about the water pollution is the emerging pollutants like the microplastics, the pesticides, the pharmaceutical waste, and the radioactive waste, which are being dumped in the water bodies. Go back. Then other is the energy issues. We know that the energy requirement is a huge, and hydropower is a major source of the energy. Next. We develop the hydropower in terms of there can be two types of plants. One is the storage based, and second is the run of the river schemes. Next. If we go in the storage based hydropower plants, then the various issues are there. You can see that the environmental flow on the downstream side is required for maintaining the rivers. Then from the water bodies, the greenhouse gas emissions are there. Then there is an issue of the sedimentation issue, which is a big issue because most of the time the sediments are flushed at the downstream. And then the submergence and the rehabilitation and resettlement issues are there. Go back. Then the climate change. In the climate change aspects in the Himalayas, cloudburst events are increasing. The flash flood events are increasing. Landslides are causing because of the flash floods, or even the Himalayan region is prone to the earthquake and extreme calamities. Next. You can see it here that in the recent times, the various buildings or the infrastructure which are there on the banks of the rivers that have gone down. So there are not much of the laws which says about the construction of the infrastructure along the bank of the rivers and various landslides. Next. Like the bridge damage or the flood hit areas in the Chamolis and those. Next. Then the cloudburst events, which has caused the flash floods and caused the various damages. Next. Then the recent avalanches induced flash floods in the Rishi Ganga and Dholi Ganga, where the water has gone down in the powerhouse, and a lot of people got buried in that. Go back. Then the anthropogenic activities. The various anthropogenic activities in the Himalayas, like the road construction, dam construction, rock squaring, mining activities, encroachment in the riverbeds, and uncontrolled tourism are causing a lot of damage to the Himalayas. So these needs to be monitored properly. Next. Like these are few pictures of the dam construction. Go back. Then the safety issues. The various safety issues are there. Then the next point is that the measurement and monitoring. So due to remoteness and the lack of connectivity, inadequate communication network and other infrastructure, it is challenging to develop and monitor and manage the response system and instrumentation in the hilly mountain regions. So there is a need for installing the monitoring stations, particularly in the Indian Himalayan region. The primary data collection issues include transportation logistics to the gauging sites, loss of facilities due to extreme flood events, and the expense of installation and maintenance of gauges. Because most of the time, this question comes that who will bear the cost for installing the various monitoring stations? Then in addition to the river basins with the steep valley walls, the wireless coverage and radio telemetry are frequently inaccessible and highly restricted choices for transmitting long-term hydrographic data and early warning systems. In India, we have the two types of the organizations. One is the Indian Meteorological Department, which is responsible for collecting the data for the meteorological related data. And there is another Central Water Commission, which is related with the water observations in the various rivers for developing the observation sites. Next. The development of water resources information system is desired at the three levels, because in Indian system, we have the three tier of the administrations. Like one is at the federal level or the central level, which needs because the water is a central issue and these are the property of the nation. Then second is the various states. The various states have their jurisdiction. So some of the data is monitored or collected by the state agencies. And third is the district level or even the private level. Some of the projects are being owned by the private agencies, so they are collecting the data. But there is no synthesization or there is no proper monitoring of the data as such or the collection of the data. The second issue is that the reliability of the data. Reliability of the data is very poor, and people are not sharing the data with each other or the scientific community, thinking that they will find out some fault in the data, right? So the reliability itself and then the lack of sharing of the data, that is the major issue. The information system with various components of surface water, groundwater, hydrometeorological observations, water quality, snow cover, interbasin transfer links, land resources, and socioeconomic parameters is very, very important. Installation of communication network and instrumentation such as automatic weather stations, rain gauges at the remote locations. Then improvement in the logistic framework and policies for the environment. Need for strong coordination among the institutes and management boards are required. The key issue is that of the investment. Who will invest? And everyone should own the stresses like the climate change. Because we are only thinking that only the government will do. But we as the citizens, we also have the responsibility. We as the developer of the projects, we have the responsibility and everything, because ultimately it is coming from the private money. So it has to be shared with scientific community so that the long-term sustainable solutions can be given to the society. So thank you very much.
Thank you, Professor Kansal. I would like to now invite Professor Sagnik, who is professor at IIT Delhi. He would be speaking on air quality management for sustainable development, perspectives for India.
Yeah, good afternoon. I just want to take the opportunity to thank the organizers for having me here. I will talk about air quality management, the perspectives for India. Now, air quality is not a new problem in India. However, unfortunately, it was not really given much importance beyond Delhi for quite a long time by our policymakers. And they were not very, they were actually very skeptical about the extent air pollution had on overall, various facets of life for quite a long time, because most of the numbers a few years ago were provided by the international community and they're very skeptical how relevant they are. So what we realized is that we need to generate some indigenous evidence to convince the policymakers the urgency. And so what we have done is that over the years, we have created a research network in our country, as well as outside with the leading scientists to generate key evidence linking air pollution to the various sustainable development goals. Now, India has also the state level estimates from the Global Burden of Disease, where we sort of established that almost 1.4% GDP loss can be attributed to air pollution. There are a lot of studies now emerging showing the crop productivity loss due to air pollution, particularly from ozone as well as PM 2.5. More than 1.6 million deaths and many more morbidity, leading to the challenge meeting SDG 3. Very recently, using the data from India, we have shown that there is a cognitive impairment for the children who are exposed to high level of air pollution at the early ages. In terms of gender equality, we have now results where it is very clear that women in India are more exposed to air pollution, particularly from the household perspectives, because a large fraction of Indian population still relies on solid fuel for cooking, and it's mostly the women in our culture who cook. In terms of energy connections, we now have estimates that because of air pollution in the last 2 decades, India has lost almost 20 plus terawatt hour loss in solar energy. And if you sort of try to translate into the economic loss, it's more than 500 million US dollar. We now have also evidence on the negative impact on labor productivity. Green infrastructure is being pushed forward. And we all know that socially vulnerable are more exposed to air pollutions, establishing connections to SDG 10. There are additional emissions from the urban areas. We need economic growth with clean environment. And finally, if you think about the SDG 13, clearly air pollution and climate are interrelated. So with the kind of evidence now, our Ministry of Environment has launched National Clean Air Program in 2019 with an aim to reduce the air quality by 20 to 30%. And their major target is to reduce PM 2.5 and PM 10, because in India, out of various air pollutants, PM 2.5 and PM 10 are the major pollutants. However, the challenge is that we do not have an adequate ground monitoring. For example, if you see the ground monitoring network, most of the, so you can see obviously that there are large gaps. Mostly we are monitoring in the urban areas, leaving the entire rural population and the background sites unmarked. And also most of the monitoring sites started from 2017 or 18. So we really do not have a very long data. And if you try to calculate what is the sort of average distance to the nearest monitor, for India, the number is 80 kilometers, which is very large. So what we have done is that, and the good thing is that our central government felt the need to augment monitoring. However, due to limited resource, obviously the ground-based monitoring cannot be expanded as rapidly as we envision. So they sort of started formally exploring use of satellite data, which is really good. So what we have done is that we put together a satellite-based PM 2.5 database. So you take aerosol optical depth data. In fact, this was also the data fusion earlier presented. So we also adopted similar approach. So we're taking and then we are filling the data gap in AOD using machine learning and models. And then eventually we have a daily PM 2.5 data product at 1 kilometer by 1 kilometer for the last 22 years. And you can see that sort of, how good is the product compared to the reference grade monitors on daily scale as well as at annual scale. Advantage is that if you have this sort of data, you can look into the seasonal cycle, you can map the entire country. And if you see it particularly in this map, and just drawing your attention on the color scale, the Indian national standard is 40 microgram per cubic meter. So, which is obviously 8 times higher than the WHO standard. One thing you can see clearly that except the Himalayas, it's nowhere actually it's meeting WHO standard. And because of so much background dust, what I believe is that for India, it is unrealistic to meet WHO standard of 5. But even for the Indian standard, if you see, most of the country, particularly during the winter time, does not meet that standard either. And in fact, the entire Indo-Gangetic plain has pollution level exceeding 120, 130 microgram per cubic meter, particularly during the winter. However, as I said that because of the National Clean Air Program, lot of initiatives have been taken. And if you see the last 5 years of data, and at a regional scale, what you are seeing here is the number of days when the 24-hour PM level exceeded our national standard. So that number has gone down over the years. So I'm ruling out 2020 because of the additional benefit from the COVID-induced lockdown. But if you see also in 2019 as well as 2021, you see more blue, less red, which is a welcome indications. Now, one of the reasons for this is penetration of the clean fuel. So we have a major government policy called Prime Minister's, so basically it's giving LPG to the rural households who cannot afford. And regional source support and studies are showing, and in fact, we have such kind of studies done. So you can see here 4 different seasons. So this is winter, then pre-monsoon, post-monsoon. And we have first of all identified the entire country into different air shades using the 2 decades of satellite data. Now within each air shade, the background color shows what is the contribution of primary PM 2.5 to total PM 2.5. And if you look into these 4 images, you see that except during monsoon, So secondary PM 2.5 has a larger contribution to overall PM 2.5. And again, this is very important because it means that we need to not just control dust, but also control the precursor gases, which is not, so if you think about the National Clean Air Program sort of initiatives, there is a lot of emphasis on primary dust control, but we keep forgetting the secondary PM 2.5 is very important. Now, in each year sets, there are different pie charts. One is, so both the pie charts are showing what are the sectoral contributions to primary and secondary. Now, it's a slightly complicated figure, but the main point I'm trying to raise from here is that whether it is primary or secondary, you see that, and this is actually at the NCAP baseline year. And if you see what is happening is that domestic and transboundary had very large contributions. Now, this is why I'm saying that over the years, as the LPG penetration is increasing, there is a sort of a regional improvement. Also, it is very clear because of the very high transboundary contributions to both primary and secondary PM 2.5. It is extremely important to go for airshed management rather than city-centric. And then the other missing point was inclusions of the health in this whole dialogue. Now, there are studies to show what is the impact of air pollution. And beyond that, based on this kind of India-specific analysis, now we are sort of engaging with the government into dialogue to set up estimates or expected benefits for various health outcomes if India made certain clean air targets. So these are the results from the India GBD studies, where you can see that the health burden for the ambient air pollution has been increasing. However, because of the clean fuel penetrations, the same for the household air pollution has been decreasing. So as a result, what is happening, these two are canceling out. So more or less, the air pollution health burden remains constant over the years. And within the disease proportions, 45% is mostly the cardiovascular, followed by 33% is respiratory. Let me skip this. So both for short and long-term exposure, we are establishing India-specific health risk functions. For example, this is for the short-term exposure. You can see that for multiple cities now, studies are done to understand the impact of acute exposure on all-cause mortality. Obviously, there is large variations. So this is for the PM10. But if you talk about PM 2.5, and you can see that the impact is much more. And particularly in Delhi, there are two studies, one based on the ground measurements, one based on the satellite data. And what we are finding is that clearly there is a large impact. Now in India, the two top health risk factors are malnutrition and air pollution. And we wanted to understand whether air pollution worsens malnutrition outcomes. And we have taken multiple disease outcomes. I'm just showing one example for anemia. Now, India has one of the highest anemia prevalence in the world. And now we have evidence that both for child and women, long-term exposure to PM 2.5 is actually enhancing the risk of anemia. And for example, for child, for every 10 microgram per meter cube increase, child anemia prevalence increases by 1.6%. For women, it is 7%. And what we have done is that based on such kind of risk functions, we calculated what is the benefit expected if India made certain clean air targets. Now, India has actually an anemia-free mission target where they're trying to reduce the anemia prevalence below 35%. And we are showing here is that this target can be accelerated if we also meet certain clean air standards. So, for example, this National Clean Air Program target, if it is met, you can see that many more districts where actually this target will be cleared. And not just for anemia, now for many other health outcomes. Now, we are also moving beyond PM 2.5 mass because we have realized that, we need to prioritize sectors. So what I'm showing here is that for different species of PM 2.5, what is the exposure? And then we have done health studies. And what we are finding is that, for example, this is a study in Delhi where we have found very higher actually associations with secondary PM 2.5 and black carbon compared to other species. Similarly, for sectoral, you can see that domestic, road dust, industry, power, and various other sectors. And this is for the women anemia. we have found that the highest impact is for industry. And with this kind of data, we are trying to engage with the government to prioritize the sectoral interventions, because we have realized that, not all the sectors can be dealt at one. Moving ahead, from 1 kilometer, we are at the city level, we are coming down to 100 meter by 100 meters. So this is a map for Delhi where you can map the municipal wards. Beyond PM 2.5 now, many other pollutants we are mapping for the entire country, like NO2, ozone, and others. I am involved with this NASA's Maya satellite mission, which is coming up and will provide continuous PM compositions for various regions. So more and more health study can be done. There's a last slide. So we have also tried to project how the air pollution will change under the climate change scenario. So it's not that one-way interactions that air pollution impacts climate, but as the climate is changing, meteorological conditions are shifting. You can see that in India, if you sort of project under two different climate change scenario, the red one is the RCP 8.5, the blue one is the RCP 4.5. This is how the PM 2.5 level is projected to change in India. And what we have done is that we have done some simulations to understand what is the climate consequence of air pollution mitigations. And here you can see that baseline versus mitigations, where if you reduce sulfur dioxide emissions and all, what will happen obviously is that with respect to baseline in the mitigation, your PM concentration in 2030 will be lower. But because you are removing scattering aerosols from the atmosphere, there will be a trade-off, and there will be an additional 0.3 to 0.5 degree warming. So we need to keep in mind that any air pollution reduction also has climate consequence. So few key takeaway messages. So we are moving towards a kind of hybrid approach in air quality management, moving from city center to airshed. Also, there is a need to move beyond PM mass and strengthen evidence for multi-pollutant exposure issue. Interventions must be prioritized for a larger health benefit and climate co-benefit. And we have realized that intersectoral coordination is in implementation is the key. And this is where also, a lot of attention has been given. So thank you for your kind attention.
So thank you, Professor Sagne. I would be finally now presenting before you the very comprehensive legal and law and policy framework for India with respect to climate change, as well as the air and water frameworks. Yeah. So when we look at the, could we go to the next slide? There are certain very important facts about India, a country of such huge proportions in size and population. It is going to exceed in terms of population China in 2023 and become the most populous country. And we would see here that net zero carbon has been declared by India for 2070. I think China, it has been in 2060, and the emission peak for India would be between 2040 and 2045, and the NDCs, which are the latest that has been updated in 2022. The emission intensity of the GDP is to reduce by 45% by 2030 and achieve a cumulative electric power installed capacity from non-fossil fuel-based energy sources by 50% by 2030. So these are two very, very major propositions which we aim to achieve, in the next few decades. Yeah. The next slide, please. Yeah. Now, when you look at the Indian environmental legal framework, it's a very, it starts with the Constitution of India, where within itself there are provisions which relate to the environment, and further on, India is a participatory state as well as a ratifying state to so many international conventions. It is also it has partaken in various soft law propositions, and consequent to that, there are these key statutory enactments relating to Water Act, Air Act, Environment Protection Act, and so on. Amongst these, I would like to draw your particular attention to Environment Protection Act of 1986, which is called umbrella legislation, and within which you would find there are a number of policy interventions that have also come up due to a very powerful provision, which is section 3, which enables the central government to take all measures which are required for the purpose of environment. Further on, the judicial response, just way back here. The next slide. The judicial response, particularly in India, is significant because it has built a lot of environmental jurisprudence due to its very innovative techniques as to public interest litigation, which involves the relaxation of local standi and many other principles that have been evolved over a period of time, especially the absolute liability principle that came in the wake of really the massive Bhopal gas tragedy of 1984. Yes, next. Yeah. So when you look at the climate change framework, it is again, it's a significant one, and it would start from more recent times, 2001 onwards. The Energy Conservation Act, the Electricity Act. In the Energy Conservation Act, there have been a number of amendments in which the energy codes, the construction codes for various buildings have been incorporated. You would find that there is a recent carbon trading mechanism that has been again integrated. We have the Disaster Management Act, Right to Information Act, which becomes a major tool in the hands of the citizens to proceed with any kind of complaint. They would have access to information through this particular act, and then they can have access to justice across the various judicial forums in India. As was mentioned earlier, the National Action Plan on Climate Change has come in since 2008. There are 8 national action plans, and these relate to, I've not specified in the slide, but these relate to sustainable habitats, solar plan, enhanced energy efficiency, water plan, the sustainability of the Himalayan ecosystem, the Green India Plan, sustainable agriculture, strategic knowledge on climate change. Recently, 3 more have been added, which relate to coastal systems, human health, and sustainable transport. So this is basically through a policy framework, which is more the predominant way of dealing with climate change rather than a very active, a formal incorporation of law. So this is something very peculiar to India. Yeah, we could go to the next slide. Yeah. The stakeholder participation is very crucial to deal with various issues. And here the government, the corporates, and the citizens, these are the 3 limbs, and they have to synergize their energies. And you would find for corporates, especially, there is the recent environmental social governance, which is becoming the norm across the world. And now we have many stipulations within the law legal framework also, which require corporates to be more accountable and responsible with respect to environment. Yes, the next slide. So when you're talking about air pollution, then of course, there are these various statistics, which again, and there are these various programs, initiatives that have been undertaken. The National Ambient Air Quality Standards, which was introduced in 2009, and later there is the Air Quality Index, which was launched in 2014. The difference basically between these two is that NAQS is more of a technical, initiative, and AQI is meant for the people. It's a people-friendly initiative where people are informed across 6 categories as to what is the status of the air pollution from good to severe. SUFFER is an indigenous state-of-the-art, major indigenous program, and this also reflects upon weather forecasting systems. Then, of course, for Delhi and the NCR region, there is a particular problem of crop burning, which you might have read in the newspapers. So stubble burning or crop burning has come up in the past few years. And to deal with this, there is a commission for air quality management that has been set up very recently in 2021 because it spans across states. So it goes across. The problem is really located in the adjacent areas of Haryana and Punjab. So this commission would really look into how to coordinate effective actions to deal with the problem. Yes, the next slide, please. Yeah. So regarding air pollution legal framework, there is again an elaborate, framework of laws. And noise is, of course, considered as part of air pollution. So you have separate noise pollution rules too. There are many landmark cases which where we would see, in fact, Taj trapezium case and the Delhi CNG case are particularly very noteworthy because a lot of technical expertise was relied upon by the courts, the apex court in India, Supreme Court, in order to really come to a conclusion as to the various strictures that really emanated from the court conclusively, and which also is a pointer as to the close collaboration that is needed of the technical and the legal and policy frameworks. The sources of pollution, the construction dust and crop burning has emerged recently, more recently, as a very disturbing and disruptive sources of pollution. There are, of course, the airshed management approach has already been mentioned as one of the ways to tackle an ICT solutions. The interlinkage between air pollution, climate change is, of course, in terms of smog and the black carbon particles. This has been spoken earlier in so many presentations, and this just needs to be emphasized more. Yes, the next slide. So water pollution is, if you look at it, India has only 4% of world's freshwater resources and 18% of the world's population. So the kind of proportion which is there is very inequitable in that sense. And water is a state subject in India, which really calls for a lot of state center coordination, and water federalism comes into the picture. The problem of groundwater is particularly, again, to be noted, and we don't have a groundwater legal framework, a formal framework. It is subsumed under the water pollution laws. And there is, however, a central groundwater in 1997 that was established, which is responsible for regulating and controlling groundwater development and management in the country. Yes, please. Next. Water pollution statutory enactments are there, and unfortunately, we are still keyed up with the Indian Easements Act of 1882. It's a very, ancient act in that sense, and where the land and water connect is there. So whoever is a landowner has full access to water, and there is not much of so the recent public trust doctrines that have featured so frequently now in various debates, they have come to the fore and they need to be accommodated within the existing scenario. The Ganga pollution case and TN Tanneries case, Tamil Nadu Tanneries case, the Kamal Nath Mehta case, these are all important cases which again highlight the relevance of the various interventions, the judicial responses have been very important here. And especially in the tanneries case, again, you would note that tanneries is a particular industry where a lot of water is used and there's a lot of pollution as a result of it. The various judgments of the apex court, they have been very extensive in their reach, but the problem also always comes in terms of the execution of the judgments. So there's a lot of contempt of various orders that come from the Supreme Court also. Yes. There is an Namami Ganga project which has been established. So Ganga is a river which is highly revered in the Indian system. And in order to just ensure its cleanliness, because it has been in various stretches, there is so much of toxicity, and this program has been established in 2014. There's a whole idea of the ETPs, which are the treatment plants, the effluent treatment plants that have to be set up compulsorily by industries. And there are a number of other regulations and other projects that have been set up. Water pricing is one issue, which is a little elusive in its, final answer. And we are still really trying to understand as to how to go about it. So in Delhi, for instance, 20,000 liters of water is given free, and there is a huge connect again between the political and the final outcomes. So there is the need to, there is a need to have this effectual final resolution on this issue. Rainwater harvesting is mandatory in certain states, but it is still not at the central level. It is still not compulsory. Watershed management, very similar to airshed management, has been proposed also for conservation of soil and so on. Yes, the next slide. So some important takeaways from India is, of course, government plays a major role and must take the lead in climate action. State action has to be integrated with the central policy. Other stakeholders must play their role. Urban-rural divide needs to be addressed, and especially the rural areas need to be looked into more carefully for the purpose of air and water pollution. Agriculture is an important focus. It should be recasting of employment prospects, vulnerable sectors to be given special attention. The air water pollution legal frameworks have, they are emergent areas of concern. Funding is a key to resolving the climate crisis. Innovation and R&D is the other factor. So awareness on climate change is so important, and it's no surprising that in a recent survey that was conducted in 2021, there were only in the list of priorities of action, climate action was very low in the list. It featured approximately 17th on the list. So, and finally, the last slide. Yeah. So the question is whether we should have a comprehensive climate change law or dispersed in an updated one. Adaptation, mitigation are both important, but adaptation, the policy, as I mentioned initially, that seems to be more needing immediate attention, particularly because of vulnerabilities. There is a perennial conflict between development and environment. So is there a need to have some alternative economic models too? Because we always try to grapple with the idea of GDP, which has its pernicious effects. Phasing down of fossil fuels. So this has been a term which has been introduced by India, and it has its own logical consequences. So sustainable lifestyle has been emphasized recently in the COP27 too. And women as an important partner is, which was mentioned by Professor Sagnik too. They really deserve that kind of attention that is needed. Yeah. So thank you so much for your attention. Thank you. So may I invite the Indian dignitaries to come in. Let's invite our esteemed audience now to come up with their questions. Of the Indian experience.
Hi, I'm Shrayan. I'm a researcher at AppSell here at NUS. I had a question for Dr. Day. We spoke, there was an earlier speaker from Peking University, I think, who was talking about multi-source as opposed to sort of traditional ground level monitoring. I was wondering if that's been looked into at all in India, or is now the focus on, because you also said there's like not enough capacity for ground level monitoring. So maybe even so maybe that's the first step, and then we move to multi-source. So that's my question. Like, is the focus now on strengthening the traditional system, or are we also looking beyond that as well? And also for Dr. Bharti, just like a more factual question. I was struck by the reduction from 2021 to 2022 in per capita GDP emissions. So I was wondering if you have any insights on that. Like, I understand how 2020 to 21 may have reduced because, or like there may be a discrepancy because of COVID, but I was interested to see the difference between 2021. If anything, I would have expected the opposite because there's been more activity going on in 2022. Yeah, thank you.
Okay, yeah. So I think it's a good question. So the focus in India is to move towards a hybrid monitoring system, which will be anchored around the, so which is basically integrating different types of monitoring. Obviously, reference grade monitors are the most accurate, but as I said, that there is not enough resource to really augment to that level. So within an airsets, the idea is to sort of use satellite to provide the regional perspective and then anchor low-cost sensors around the reference grade monitors to provide hyperlocal information. So you have both information spatially and temporally. And then if you also include in this sort of observational design instruments which provide PM and other PM composition as well as monitoring other key pollutants. So that is where actually the observations for air pollution is moving.
As far as the GDP is concerned, there is no gain change methodology. It's mainly due to the kind of effects of the pandemic that were observed.
I was talking about the per capita
Yeah. So the further calculation has to be per capita. There is not even any change, any drastic or substantive change in various parameters. So it is most likely to be connected to the pandemic after effects. So it is going to pick up. It's going to be more real after a couple of years.
Yes, I'm wondering about the aerosol optical properties to be able to properly use. Sorry. No. Oh, sorry. So let's go again. I'm wondering about the aerosol optical properties to be able to make proper use of satellite products.
I would say yes. I mean, although India does not have dedicated satellite to measure aerosol optical depth or other properties, but we have actually a geostationary satellite, but most of my work is actually utilizing other satellites, from NASA or European satellite, but which we are utilizing to develop various products, which I explained. India is also sort of thinking in having a dedicated satellite mission.
I mean, no, it's not a problem where you take the satellite imaginary. I'm asking about the physical characteristics of the aerosols. To be able to retrieve a proper aerosol optical depth, you need to know about the optical properties of the aerosols.
Yeah, so there are, I think more than now, we are able to do that. And in India, we have a network maintained by Indian Space Research Organization. So this network consists of more than now 40 sites where at least from ground, you're measuring aerosol optical depth. There are instruments which are providing aerosol size distribution, black carbon and various other aerosol mass, using which actually there has been extensive evaluation of multiple satellite data products. And now they are routinely assimilated into modeling framework for various other applications. Yes.
In the United States, one of the difficulties with establishing effective climate change policies federally is that different regions in the United States have economies that depend more or less on fossil fuels. I was wondering if similar situations in India exist in terms of different dependencies upon fossil fuel in different regions.
There's a lot of dependence of the states on the union, especially in terms of finance. So there is a finance commission which which really looks into the devolution of finances to the states. And this time they have evolved upon different criteria, and now for the first time, environmental criterion is featuring. But yes, there is undoubtedly that kind of dependency is there because of the financial constraints which come in. So, because they're so, the whole tax devolution structures, they are formulated in such a way that and of course, there are grants and there are various other forms by which the sector can intervene and can help the states. But the problem is very much there. And then the problem of the political also comes in because, it depends on what governments are there, the center and the states, and to what extent, that correspondence is there.